Greetings, Leon. Noah. Hope all is well and everything's going well with your moving and such. Um, yeah, I was just responsible for teaching you today about the derivative of sine and cosine. So sine and cosine in this sense is dealing with the unit circle. And right now, uh, we're just going to be plotting points in the beginning. So let's just look at the circle right now. The circle has all these different degrees on it. 0, 90, 180, 270, 360. Whether you see beside them or below them, you can see y and x coordinates, and we're right now plotting it on the first graph. So the first point at 0, y would be at 0. Simple enough. And the next point, 90, y would be at 1. At 180, 0 again. Then 270 will be at -1. And then at 360, back at 0. So let me draw this out really quick and get into cosine, or the derivative of, wait, not cosine, the derivative of sine. Derivative of sine, uh, you find it by looking at the slope right here with the graph. So right now, this is what we're learning. Well, I'm going to show you a different way in a second. So at 0, the slope is 1 because it's about to go up. So seeing that it's about to go up, it's going to be 1, excuse me, the slope is going to be 1. So we would put 1 right here. Excuse me. Yeah, we'll put 1 right there at the first point. And then in the next point, we would make it 0 because it plateaued for a bit. Then for 180, it's going to be -1 because it's going down. And at 270, it's going to plateau. And we usually see at the end of the curve. And now when we go back to 360, it's going to be not -1, 1. So yeah, if you haven't noticed, if you kind of step back and notice, you can see that when I name the slopes, they are kind of correlating to the x values. So at 0, it's 1. At 90, it's 0. At 180, it's -1. At 270, it's going to be 0 again. And at 360, when it comes back around, it's going to be 1. So that's what we're going to be talking about next. Well, plotting next, which will be cosine. So cosine at 1. Well, let me take a step back. Sine is the y values out of circle. So the different at each point from 0 to 360, all the y values, you would take those and then use the radius of the circle, which we're using 1 right now. So you see on the graph, the maximum is +1 and the minimum is -1. So the radius, you use the radius, and also then for your y point, and you would use for your x points for the graph is the degrees. Excuse me. So yeah, but to simplify that, we would just say the function is sin x. So which is what you would do for that. Wait, hopefully I'm explaining that right. So to make those graphs, you would use the degrees as your x points and the radius as your y point. And for the first point, well, the first graph, we would use the y points. Then for the second graph, instead of using the y points, we use the derivative of the y points, which also is the x points on the circle. So it's simpler just to see the x points on the circle when you're doing calculations. But if you don't have it, you just use the derivative of the y points because the y points are the derivative of sine is just the x points. So the derivative of sine is cosine, simply put. So what you would do then is just now at 0, x is at, the point will be at 1, 2. For at 90, the point will be 0. At 180, it will be at -1. And 270, it will be at 0 again. 360, +1. Hopefully, I'm not confusing you at this point, and you're still with me. So let's graph this out. Excuse me, mess those points up. All right. So yeah, but since we found out what the derivative of sine is, what is the derivative of cosine? And you probably already know this since I put it up there. The derivative of cosine is negative sine, which doesn't make any sense. Should have been tangent. I'm calling the authority. I'm calling the government to rework this because this is mad annoying. But anyways, I'll bite my tongue for now and just teach you this very incorrect wording. Should have been tangent, but anyways. To kind of find the derivative of cosine, you gotta first find the derivative of the x's or the x points on the graph of cosine. So let's draw it out. So at 1, it will be -1 since, well, at 0, it would be -1 because it's going down. At 90, it would be 0 because it stopped for a second there. And at 180, it will be positive because it's going up, or starts to go up. To 70, it would be 0. Yes, it's 0. And at 360, it would be a positive slope. So you notice you can kind of see that it correlates to this. Well, not really, but some of the coordinates match up with sine and being negative. So yeah, working this out with, so to graph this, you would use the slope of the derivative of cosine at those axes. So the first one was -1. We put -1 right here. And then at 90, it would be 0. At 180, it would be positive 1. At 270, it would be 0 again. And 360, back at uh back at 0. Not 0, negative 1. So when we graph all this out, oh gosh, it would make that kind of curve. And thank goodness I am not finding the derivative of negative sine, because I would be crying. Hopefully this kind of gives you an understanding of how to find the derivative of sine and cosine. And if you can kind of see, they're kind of wavy graphs because you have a circle and the circle comes for a circle. So if you start at 0, you're going to end at 0 for sine. So if you start at 0 and then 360, it's going to be, they're both going to be 0, you know that. And for 0 and 360 for the cosine, is going to be both at the value of 1. And for negative sine, is going to be at negative values for 0 and 360. Hopefully, fingers crossed, on dead Jesus's corpse, you will understand this. Because if you don't, I have to write all of this out because it won't save. Please. Please tell me you understand this. Hope all is well. See you soon. Hopefully next week. And again, hopefully you understand this.